Hi everyone, this is called Limits by Plugging In. And if we were in class, I would ask you to fill in this table, and our function is y equals x squared. So if x is -3, -3 squared is 9. If x is -2, -2 squared is 4, -1 squared is 1, and so on. And then we would graph these points. Sorry, my stylus is being weird. And I know that you already know what y equals x squared looks like, but we would graph -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And we would graph that parabola. I'm not going to redraw that, you get the idea. And then it says using your graph. So I'm over here now. Using your graph, what is the two-sided limit as x goes to 2? So there's not a little plus sign. It's not x going to 2 from the smaller numbers, or x going to 2 from the bigger numbers. It's just the two-sided limit, x going to 2. So you look at 2. I am going to fix this. And you look as x goes to 2 from the smaller numbers, we're looking here. From the bigger numbers, we're looking here. And here is x equals 2 right here. So no matter if you come from the left side or the right side, as x goes to 2, I'm getting closer and closer to that y value right there of 4. And so that two-sided limit is going to be 4. Looking at x going to 0. So again, that's a two-sided limit. So you're looking at x going to 0. So here's 0 right here. And it's not 0 going towards 0 from the left. It's not going towards 0 from the right. It's just the two-sided limit. And this does exist because no matter if you come from the left or the right, as I go towards x equals 0 from either side, I'm approaching a y value of 0. The next one is -3. -3, sorry, it happens every time. -3 is over here, right here. So this two-sided limit also does exist because if you come from the smaller numbers or the bigger numbers, either way, as you go towards x equals -3 from either side, you're going towards the y value there of 9. And then the last set of examples does include left-hand limit and right-hand limit. So this is a little bit more what you're familiar with. So the first one is going towards 1 from the bigger numbers. So here is 1 right here. So as you come from the numbers that are bigger than 1, you're going this way. And you're going towards x equals 1 from the bigger numbers. And the y value we're getting closer and closer to is 1. If you go towards 1 from the smaller numbers, you're doing this, right? You're coming from the smaller numbers and you're going towards x equals 1, and you're still getting closer and closer to that y value of 1. And letter F is the two-sided limit. So because the left-hand limit and the right-hand limit were both 1, that two-sided limit is also 1, and it exists and it's 1. That statement is also saying no matter what side you approach from, if you come from the smaller numbers or the bigger numbers and you go towards that x equals 1, you're getting closer to that y value of 1. So then I would ask you to look at those limits that we just filled out and see if you can think of a shortcut for how to get those limits besides making a table, drawing the graph, using the graph to get the limits. So as x goes to 2, we had a limit of 4. As x goes to 0, we had a limit of 0. As x goes to -3, we had a limit of 9. And then all the limits as x went to 1 from the left, from the right, from both sides, those were all 1. So I would ask you to stop and talk to the person next to you, probably to see if you could find a shortcut for how to get those answers without looking at the graph. And maybe you realize that you can take the x value and plug it in to the function y equals x squared. So what I mean by that, if that doesn't make sense to you, your function was y equals x squared. And this number 2, so 2 squared is 4, 0 squared is 0, negative 3 squared is 9, 1 squared is 1, 1 squared is 1, and 1 squared is 1. So that's kind of the first thing that we learn, the first approach that we take. Instead of doing the graph by hand and using the graph to find limits, sometimes you can just plug in the number and get the answer. So we would call that a shortcut. And this example right here, the limit as x goes to 1 of that function 3x minus 9. So instead of graphing it, plotting points, looking at the graph, finding the limit, you could try and just plug in the 1. So 3 times 1 minus 9. So that 1 got plugged in for the x value, and we get negative 6. And that is the limit. And normally we would not then look at the graph, but you always could do that if you wanted to. So I have included it here, the graph of 3x minus 9, and we're doing the limit as x goes to 1. So obviously this is linear, and here's 1 on the graph. And so no matter if you come from the left side or the right side, you're getting that same limit right there, which is negative 6, right? The y value there is negative 6. So plugging in is kind of the first thing that we look at to get the answer. And it doesn't always work, but that will be in future lessons. All right, so then I wanted to just show one more that's a little bit weird is number 1. So the function is actually 12, and that's the same as y equals 12. So that graphically, y equals 12 is a horizontal line, and we're doing the limit as x goes to 5. So let's say 5 is here. So no matter if you approach x equals 5 from the left or from the right, the y value there is going to be 12. On that horizontal line, the y value is actually always 12. So as x goes to 5, you can approach from the left and the right, but the y value is 12. So that's the graphical view of that one. Algebraically, if you're thinking about, I'm going to plug in 5 for x, well, there is no x value there. There's nowhere to plug in 5, so your output is just 12. You might see some of those on the worksheet. Otherwise, they're going to look like this. Number 3, this is the last one I'll show you. And this entire worksheet, you're just going to plug in your x value. One thing, well, here's how you're going to write that. 4 times 2 equals 8. So as soon as you plug in that 2, you don't write the limit statement anymore. You just do 4 times that x value of 2, and you get your answer of 8. The notation that we're using, we'll talk more about that next week as well, because it'll get a little bit more complicated. So there's a few examples for you to try. Here's the first one. The limit as x goes to 0 of x squared minus 25 over x squared minus 4x minus 5. So take a minute and try that one and see what you get. So you'd write an equal sign, and you're just plugging in that 0 for x. And you have 0 squared minus 25 over 0 squared minus 4 times 0 minus 5. So the top would be negative 25. Those are both zeros, and we have a negative 5 on the bottom. So you should have an answer of 5. Okay, next one, part B. Go ahead and take a minute and try that one. So we'd have an equal sign. We're plugging in negative 2. So negative 2 squared minus 4 times negative 2 plus 1. It's great practice to see if you can do this without a calculator as well. Negative 2 squared is 4. Negative 4 and negative 2, that'd be a positive 8 plus 1, which comes to 13. And the very last one for you to try, go ahead. We have 2 times negative 2 minus 6, negative 2 minus 2. That is negative 4 minus 6 over negative 4, negative 10 over negative 4, which is 5 over 2. Or you could have 2.5. Okay, so that is limits by plugging in. Hopefully it's pretty straightforward and that should help you with the worksheet with the same title. Great job.